Hi everyone, this is Brian Fogarty, and in this video what we're going to do is look at how to plot predicted probabilities using GGPLOT2 from a LOGIT regression. So this video, again, as the other ones in this set have been, follows from the previous one where we're using the Scottish census data, alright, and did some manipulation, etc. So this was the regression model that we had. Okay, I just reran it here. All right, again, everything is statistically significant. And so one of the things that we like to do is to plot results because they can tell a lot about what's going on. So in the previous video, we looked at how to do individual and group predicted probabilities. And I mentioned that sometimes they're not that useful when you want to give sort of the whole picture of what's going on instead of very particular value. So we can do that with plotting predicted probabilities. Now to do this in R, it's not easy at all. Although at the same time, if you think about some of the other programs exist, like Stata, it's not very easy to do that. It's not easy to do it in Stata either. And so we're going to go through the whole process of how to create a predicted probability graph here using GGPLOT2. And then just look at a few different options. There's so many different options you could do with ggplot. We're just going to look at just a handful of them. All right. So what we want to do is we're going to plot the values for gender. So those are going to be the lines in our plot. And so what we want to do is actually create a new version of gender that is a factorial version. So there might be that already. But we just want to make it very specifically clear. Okay, so we're going to rerun this. Okay, so I'm just going to create a new variable called gender fac. So gender underscore fac, and then the assignment operator, and then we have as factor, and then data, which is our data set name, and gender. Okay. And so let's run that. All right, so we had no errors from that. Let's just double check the class on it just to make sure it is correctly a factorial. All right. Okay, so now once we have that, what we want to do is rerun this regression with this new variable. So the results are going to be the same. It's just going to look slightly different in the output. All right, so instead of gender, we have gender fac. Okay, so let's highlight that and run that. Okay, so if we come down here, we see the results are the same, just the name of that gender variable is slightly different. Okay, the next thing we're going to do is create a new data frame for our predicted probabilities here. So we're going to call this new data. Okay, use the assignment operator. Then we're going to use the with function. So with and then data, which is our name of our data set. Again, if you have a different name for a data set, it's whatever that's going to be called. All right, I'm going to enter in and then a data.frame. Okay, and then what we're going to do is we have to include in this new data frame all of the predictor variables that we use. So here we had 3 of them. So if you have 3, you have to do 3 of them. 4, if you have to do 4 of them, etc. Okay, and so what you have to do in this is think about what is your x-axis variable in the plot. So what do you want that to be? So what we're going to use here is general health. So these have 5 values on it. So we're going to start this new data frame with general underscore health. Okay, equals, and now this is a bit of sort of not advanced code necessarily, but just more advanced than what we've seen before. We're going to do rep, which is short for replicate, seek, which is short for sequence, all right, and then from equals 1, all right, comma, 2 equals 5. And now the reason we have 1 to 5 is because general health goes from 1 to 5. All right, so this is going to be our x-axis variable. So whatever you are using, that's going to change that value. So for instance, if your variable goes from 1 to 7, it'll be from 1 equals, sorry, go from equals 1 to 2 equals 7. All right, next we're going to use this option length out. Okay, and so length out equals 100. And so what we're saying is give us 100 values here. I'm just going to try to put this, I want this to look better. Let's pull this back. I like doing code where it kind of lines up to some extent. And given that I've increased the font size on this, I can't squeeze it in as nice as I'm used to. All right, so we're going to do length out. So we're going to get 100 individual values from 1 to 5. And the reason why we do that is just aesthetics. It will make our predicted probability lines look better. It'll make them look smoother. All right, so just outside that first parenthesis, we're going to do comma 2. And the reason why we're doing comma 2 is we're going to ask it to do it twice. And this is based on the lines that we're going to plot. So we have 2 values in our gender fact variable. So we want to have it do the sequence, the replicate sequence from 1 to 5 100 times for the first value of gender fact, and then do it from 1 to 5 100 times for the second one. All right, so that's going to give us these really nice lines. If you don't include this, what it's going to look like is sort of linear shaped lines, and they're going to change their slope at each value of your x-axis variable. Okay, so outside that second close parenthesis, we're going to do a comma and then hit enter, go down to the next line. All right, now for the variables that you're not plotting, you want to set them at their means. So we're going to set marital dummy, which above we included as a numeric variable, so we're able to set it at its mean. All right, so we do equals mean and then just the name of it, marital dummy. All right, and then as we did before in the previous video, we're going to do NA remove equals true. Okay, go outside that first close parenthesis, include a comma, then go down to the next line. And now we're going to include our factorial variable here. So gender underscore fact, and then we're going to do factor. All right, and then the same replicate option, 0 through 1. There's only 2 values here, so it's 0 through 1, and then comma each equals 100. So this is going to line up to what it does above. Okay, so that's our new data frame here that we're going to use to get our predicted probability. So let's run this, and hopefully it didn't make any errors here. I made some errors. All right, let's figure out what did I do wrong. All right, hold on a minute. All right, so I caught it. For some reason I put by equals here, which I think I was saying it instead of doing it. All right, let's see if that takes care of that. I'm just double checking here. Hopefully it'll work. All right, goodness. All right, so one of the things that if you're using R for the first time that you will learn is that it's very easy to make mistakes. All right, and so you just saw one there. I included some random bit of code which didn't make any sense at all. Okay, so if we want to just take a quick look at what this new data frame looks like, so new data. All right, so we'll see here that for general health, it's increasing by roughly 0.0404, and that's corresponding to this doing it 1 through 5 100 times. So what that is it's if you take the difference between 1 and 5, so your minimum and maximum, or maximum minimum, all right, and then divide that into your length out, that's going to be the change it's making for each one. All right, so if you do 4 times 100, or sorry, 4 divided by 100, you're going to get roughly 0.04. Okay, and then we can see what the other side of this looks like. So if we use the tail function, All right, this is the 5 up here, and then the gender fact is 1 here, where before when it started out it was gender fact 0. Okay. All right, next what we're going to do is combine our new data frame with predictions from our model. So we're going to create a new data frame called data2. All right, and we're going to use the cbind function. And so we do cbind and then new data, comma, predict, okay, which we looked at in the previous video, model 1, all right, our new data, and then what type we want the link, okay, and then the other thing that we want, which we'll be able to use for creating confidence intervals, is SE equals true for the standard errors. Okay, so let's run that. Hopefully there's no errors from that. Okay, so that ran fine. Okay, I'm just going to give myself a little space. Okay, so next what we're going to do is get the predicted probabilities. So here how we're going to do it is we're going to add it to our existing data frame. So we're going to do new data 2, the assignment operator, and then within, all right, new data 2, comma, and then we're going to use the curly bracket. We're going to call this predicted prob, all right, assignment operator, and then plogis fit. And so the plogis function gives us the CDF of the logit line. Okay, so we have that and that. So let's just run this here and take a look, see if it worked. All right, and then if we want to take a look at what this new data frame looks like, we can just do head new data 2. All right, so you can see here it's a little pushed around in this window, but we have these values here. We have the fit, the standard error, and we have the predicted probabilities right here. Okay. All right. The next thing we're going to do is include some labels to our variables. Okay, so specifically the lines that we are plotting. So I'm going to use a somewhat outdated package to do this, but again, as I tell students, if it works, it works. We're going to use the plier package, all right, and we're going to use the map values function. And so what we're going to do for this is we're just going to use this to get, we're just going to use this to add labels to our for our lines. So I'm going to create a new variable called gender uppercase, and the reason why I'm going to call it gender uppercase just so that it looks better in the plot itself. Okay, I'm going to use the assignment operator, and then I'm going to do as factor. Okay, so we're going to wrap this around the map values function. So map values, new data 2, gender fac. All right. And then with this, what we need to do is set what the values go from. All right. So first we're going to do from, all right, equals. We're going to use a concatenate function. And right now there's 0, all right, and 1. All right, so we go outside of that first closed, do comma, I'm going to go down the next line, and then 2 equals, and then this is what we want them to be named. So we're going to do 0 dot men, and then 1, we need the quotes there, 1 dot women. All right, so that should all look, all right, so that worked. So if we do a table, just take a quick look at this. So new data 2, gender. All right, so this is what it looks like now. So again, it looks like these values now because of how we set it up in R to do the predicted probabilities. Okay, So that's all the sort of work to do before actually running the code to do the plot itself. So I'm just going to create a new code chunk here. All right. So we're going to use GGPLOT2 as I mentioned. So we're going to do library GGPLOT2. All right, and this is going to tell me that it is, I'm using I must have ran it previously. It's just going to give me a little warning saying that it was built under a newer version. All right, so let's do the most basic plot we can do here. So we're going to use the ggplot function, and then data equals new data2. So we set the data, and then we set the AES for aesthetics. All right, x equals general underscore health. All right, and then y equals our predicted prob. All right, so that's just saying on the x-axis we want the general health, and on the y we want the predicted probabilities. Okay, so we go outside those two double closed, hit the plus sign, go down to the next line, and here what we're going to do is use the geom_line function. So geom_line, and then mapping. All right, because this is where we're setting the colors. So we set the axis above, now we're setting the colors and the lines. All right, we're going to do AES, and then color. We're just going to use the British version. The American version works the same. Gender. All right, and then you can play around. I'm just going to put size equals 1. You can play around with the size of this if you want. Okay, so let's highlight this and run it and take a look at our plot. All right, so again, it's going to look all messed up here. Let's click on the zoom and maximize that. All right, so this is the plot we get from it. So when you're looking at these plots, what you want to do is look to see, there's kind of two main things. One, what happens to the lines as you increase on this x-axis here, right? So for both of these, for both men and women, they're increasing. And then the other thing you want to do is look at what is the difference between these lines. All right, so we see that across all values of general health, men have a higher predicted probability of being employed than women do. All right, so that's the most basic version of this we can do. Now, if you wanted to add confidence intervals here, I'm just going to put CIs. It's fairly easy to do with the LOGIT, the sort of standard LOGIT regression. Some of the other more advanced regressions, it's more difficult to do. All right, to do this, I'm going to redo our new data2 DataFrame. I'm going to repeat some code here. I'm going to do within new data2, and then comma, curly bracket, and then this is what we had before. I'm just doing it just to make sure that it doesn't get messed up. So predicted prob, assignment operator, plogis, fit. Okay. And then what we're going to do is create an upper and lower bound for the confidence intervals. So first we'll do the lower, which I'm going to call LL. All right, assignment operator, and then plogis, and then fit minus 1.96 times SE fit. So the 1.96 is being used for the 95% confidence interval. So this will change depending on what kind of confidence intervals that you want to use. All right, and then we'll do also the upper limit or the upper bound here, and so it's the same thing. It's just that it's plus instead of minus. All right, so plus 1.96 times SE fit. All right, so let's highlight this and run this. Okay, so we didn't get any errors from that. All right, so I'm going to steal this code from up above, the ggplot code, and paste it down here. Okay, and so the code itself is going to be the same, except we just add in one extra line. We're going to do plus, and we're going to use geom ribbon. All right. So it sounds literally, so the geom ribbon is exactly what it sounds like. It's like putting a ribbon around it. All right. So we're going to do mapping equals AES, and then we're going to use this version here, ymin equals LL for our lower bound, and then Y max equals UL, and then fill is our variable gender. And then one last thing we're going to do is just make the confidence intervals to be more transparent. We're going to change the shading here. We're going to do alpha equals 0.2. Okay, so is that all lined up? I think so. All right, so let's take this and highlight the code and run it. All right, so let's maximize this here. Okay, so you can see the confidence intervals around them. They're pretty small because our data set has so many observations. And so the confidence intervals are much smaller when you have a large number of observations. All right. Okay, so the next thing we're going to do here is take a look at how about, let's dress up this plot some more. All right, because that was pretty, so it's nice, pretty pictures, but if we want to actually make it look like something we would do in a presentation or put it in a paper or something like that, we want to add more things to it. So I'm going to call this dressing up. All right, so let's steal, we're going to, we don't do anything new in terms of creating values. We just have to add to the ggplot code. All right, and the ggplot, there's so many options you could possibly do. It's a bit insane. What we're going to do is we're going to add labels and then also adjust the sizes of those labels. So to do the labels, we're going to use the labs option here. So we have labs. All right, first the order doesn't matter how you do this, but we're going to do y equals predicted probability. All right, x equals general health. All right, I'm just going to come down here, and then title equals, we're going to do predicted probability. There we go, probability of being employed. All right, so that gives us the actual names of the labels. To change the size of them, we can use the theme option in ggplot. So we're going to do theme, and there's a whole bunch of theme things you can do. We're going to do plot title, all right, equals element underscore text, and then size equals 20, and then face equals bold. So what that does is that it changes the size of the title, which will be predicted probability of being employed, to size 20, font size 20, and then it also makes it bold. All right, and then you can play around. I'm just going to put this in, but you know, one of these things is you do the plot and then figure out, like, do I need to make this bigger or do I need to make this smaller? We can do axis title. Let's do the X here. So element underscore text, and we'll just change the size to 14. All right, axis title Y equals element text, and then size 14. And again, you could play around. There's again a whole. I got to do equals here. You could play. There's a whole bunch of options you can play around with. All right. So let's highlight this and then take a look. See what this looks like. Hopefully it works. All right. Let me click on the zoom. Okay, so you get this nice, now better looking plot from this. All right, where you have the labels and you have the font size looking better. So this is very good to use, especially when you're doing some kind of presentation. Because if you just use the default ones, no one's going to be able to read the size of that. All right. Let's see, what else did we want to do? One of the things we can do is change. All right, so yeah, I want to show this. So I'm just going to copy this code here. So you could be in a situation where you didn't label that variable previously and you want to change the label of your legend, all right? And to do that, it's actually pretty easy. So what I did is just take the code from above and just pasted it in below. And then I'm just going to add an extra label. And so we're going to add in here color equals gender. All right, so again, so like if you went back and so we created that new variable called gender, but it was from gender fact. If we didn't do that and you want to get rid of gender fact but didn't want to redo the variable itself, you can just change the name on it. All right, and the reason why we call it color is because it's giving us these color lines, and you can see up here the geom line mapping, we're saying color equals gender. All right, and you also might want to change the size of this as well. So if we add in here, legend dot title equals, and then element, need to spell, element underscore text, and then size equals 14. Okay. Why is that grumpy? Why am I getting a grumpy message here? I don't see what the problem is. I don't see what the problem is. All right, it went away. So let's highlight this. Okay, and then if you click on this and we just maximize it, if you go back, you'll see actually the gender here now is bigger. Okay. One other thing just to show you, so again, there's so many different options you can include with ggplot. If you want to put like a caption on this, which we might want to do if we are, saying, like specifying, what's the data. So what we can do is just put a label in this. So I'm just going to, after color gender, I'm going to go down and do caption and just say data from 2011 Scottish Census. All right, and I'm not going to change the size of that. You can change the size if you want to. We highlight this and run that and just maximize it. So you see it's down right over here. All right, so that's it for this video. I know it's kind of long, but it's not easy work doing these predictive probabilities in R to make them look nice, but I think the payoff is definitely worth it. So like the video if you like it, subscribe if you haven't, and I'll see you next time. Thanks. Bye.